So next up is Paul Berger. Paul, do you want to share your screen? So I've known Paul since way back when, which makes Paul really old. He's currently the Alaska Regional Hydrologist for the National Park Service. He was the hydrologist at Carlsbad Caverns, and he's done significant work in Lechuguilla since 1988. He's an active mapper and cartographer. He co-authored Deep Secrets. And if you want to know what he's like when he gets silly, share a milkshake with him. Paul, are you there?
Thanks a lot, Pat, for that introduction. And thanks, Harvey, for lumping me into such prestigious company there in your talk. I'm going to talk about not as much of the actual formation of the cave and the chemistry of it, but concentrating really on some work that I've been doing to look at basically the structural controls of cave development. And the Guadalupe is mostly focusing obviously on the caves I spent a lot of time in, Lechuguilla, Carlsbad, Spider, and Virgin Cave, but it pretty much applies universally. I'm going to talk a little bit about the geologic setting, and then look at the influences of the regional structure on cave development, some on local structures, and then really get into some of the weeds, the nice geeky stuff with some of the syndepositional faulting, which is some more recent work. Obviously, most of the people on this talk have been to the cave or have at least seen this diagram. This is kind of a physiographic map showing Carlsbad Cavern in relation to the city of Carlsbad, the Pecos River, which serves as the current base level for the hydrology in the area, and then you can sort of see how the Guadalupe Mountains swings around through Carlsbad Cavern area, and that basically reflects the front of the reef deposit itself. In cross-section, this is a basic stratigraphy that almost anyone who's done any geology in the Guads has seen and or used or modified this particular diagram. Most of the key features are the massive limestone, which is the Capitan Formation, which is actually broken into two units, a massive, basically unbedded unit, and then the foreslope, which is also known as the Four Reef Breccia, and then the back reef units, the Tansel, Yates, and Seven Rivers, and that's the bedded alternating siltstone and dolomite units that you see in the upper parts of the caves, and you've seen in so many of the spectacular photographs we saw, particularly yesterday. One of the key factors of the Capitan and why it's such an impressive fossil deposit is that it's characterized by very early cementation of the limestone. Basically, as it was being deposited, it was cemented into rock very, very early. So it had very limited initial porosity. That's why so many of the fossils are preserved, because you didn't end up with a lot of fluids moving through the rock later that would actually alternate the fossils or turn the whole thing into dolomite. So this is looking at some of the regional structural trends. The surface trends you'll see look very similar to the lineament map that Jim showed earlier that was related to the BLM EIS. Some of these lines are the same as the ones on those, and others are ones I generated off of the aerial photography. And then the Lechuguilla Cave trends as published by Palmer and Palmer in 2000. And then the Carlsbad Cavern trends are ones that I've taken from the survey data themselves. And you can see by looking at these rose diagrams, which is basically a radial histogram, that you see pretty similar characteristics between the surface trends and the cave trends. You basically have a set of fractures that's parallel to the reef trend, one that's perpendicular, and then a couple more minor sets that are kind of orthogonal to those other two sets. But you see that consistently throughout the Guads, and as you move to the south and then the reef is kind of bending a little more southward, you see that overall trend also kind of swing and reflect those changes. So that says that regional structure has had a lot to do with the overall cave patterns in the Guadalupes. You also have in the Guads some local structural trends. This is a line plot, kind of a fat line plot of dry cave, which is centered around kind of a local structural high. It's almost like a miniature version of wind cave, where you've got these radial fractures coming away from this central point that is strongly influenced cave development, and you end up with basically these passages that radiate out from the center. So you can still have this pretty significant fracture control even on a local level. And then some of the cool stuff here is the syndepositional faulting, and that's basically faulting that's been active since the Permian time. So during deposition of the reef, these faults were actually active. So the underlying rock, as more was deposited on top of it, was actually moving. And on the downthrown sides of these faults, you have more accommodation space. So basically more room for sediment to pile up. So the same unit actually ends up being thicker on the downthrown side. Most of these are dip slip, which means they're sliding downward along the fault plane. And some of the displacement is up to 30 meters parallel to the shelf margin. So these features are segmented vertically and laterally, which means they're not super long continuous features, but actually kind of break into kind of a grid. And then they, as you can see from this diagram, they're extremely steep dips. And like I said, they grew incrementally during deposition of the Yates and Tansel formations in particular. And some of the expression of these syndepositional faults have actually been seen for quite a while. There's offset bedding, where you can actually see the faults themselves. And these actually acted as paleohydrologic boundaries because of fill inside of those. You end up with draping of the back reef units across the faults. And what that ended up looking like are these local forms that actually look like they're slight folds, and were frequently identified as small local aneclines. And one of those can actually be seen in the entrance of Lechuguilla Cave, I believe first identified by Dave Yagnow during his work, that noted that there was a little anecline right at the entrance of the cave. There are a number of other caves in the park and in the Guadalupes that also have this same look, where you actually have what looks like an anecline, but is actually the top edge of one of these big faults. Some of these open fractures filled with shelf sediment, and those are what old literature always called Neptunian dikes, but I generally prefer the term Neptunian fissure, because a dike for most geologists sort of implies this igneous intrusion. But it was really an open fracture that allowed sediment to move down in it. And there's some pretty spectacular examples that I'll show you in map form inside some of the caves. One of the big things that these fractures provided was actually a pathway for fluids moving through the rock. Like I said earlier, the Capitan itself was a pretty tight rock, meaning that there was not a lot of porosity. So if you wanted to get any kind of water moving through, you need to have these areas of weakness to concentrate that flow. So early on, and this is even back in Permian time, there was early dissolution of those fissures that actually caused paleo caverns to be formed. So there are some early dissolution breccias that have been identified throughout the Guads. Another expression of these syndepositional faults and the fluid flow going through them are these resistant bedrock fins that you can see in some of the surface canyons. Yagnow, and then a little bit later, Carol Hill noted that there seemed to be a good correlation between these rock fins and cave passages and cave entrance locations. But they didn't go into a lot of depth explaining why this was. Other work that was done by Leslie Malim showed that there was actually preferred dolomatization in these fins, which is why they're more resistant. Again, without specifically identifying that these were old fractures or faults that fluid had moved through. But the dolomatization is an example of fluid moving through and altering the surrounding rock. One of the cool things in the caves, things to look for, especially, you know, as cavers when we're looking for a new passage, is these vertical tabular breccia zones and Neptunian fissures do correlate with the limited vertical connections between cave levels, particularly identifiable in Lechuguilla Cave. Some of the examples that I'll point out is Sulphur Shores is one of these features. And then Lake of the White Roses is another one of these deep features that when you look at the bedrock are actually surrounded by these breccia zones. This is a map of Carlsbad Cavern, well, a line plot of Carlsbad Cavern, showing some of the breccia zones and some of the mapped Neptunian fissures. The kind of purple dots are the ones where the Neptunian fissures show up in the inventory, but have not been mapped as far as their orientation. So you can see a big component of the Guadalupe room is lined up right with one of these features. And the connection between the New Mexico room and Chocolate High is right along one of these Neptunian fissures. When Carol Hill published her thesis, there was a supposition that maybe some of those basinal sediments actually kind of fingered up into the main reef, and I believe it was Bell Canyon Formation or something that she had mapped up there. But it turns out that that's one of these big vertical features, probably associated with some displacement of the reef faults, the syndepositional features that then allowed that later pathway that allowed that connection between kind of the main New Mexico room level and then the area that ended up being found later, Chocolate High. The red dots show the silt matrix breccia, which tend to be up in the back reef units where obviously you've got more silt. And then the blue dots are places where there's calcite matrix breccia. And I'll talk a little bit more about problems with the calcite matrix breccia in just a little bit. Now in Lechuguilla Cave, obviously it gives us a much bigger laboratory for looking at these different features. And there's a lot going on in this diagram, so I'll kind of cover it. The kind of pink stippled areas, which you can see Apricot Dome down to Lake of the White Roses, those are actually mapped breccia zones. And like I said, both of those also are connections as far as from lower levels to upper levels. In the case of Lake of the White Roses, obviously that's the breccia fissure that goes all the way down to the deep point and gets down to the groundwater table. And then Apricot Dome is one of these breccia zones that actually connects the lower Near East with the upper Near East stuff, the ghost town Hootenholler Hall area. And it's that fissure that it brought all that iron and manganese mineralization down from those back reef units to Russicles. The bottom of Apricot Dome is basically where Russicles is and is the source of all the iron that makes those cool, groovy formations. Now, what I've got in the kind of beige dots are all the places in the inventory as of when I made this particular map of where there are these Neptunian fissures. One of the ones people are mostly familiar with is like the big one that's at the Big Sky Camp. That's a real obvious one. And then the red features are actual in-cave mapped faults. And if you notice, there's a really pronounced one right at the entrance. It actually goes from the entrance all the way through Glacier Bay. And it was interesting hearing Max talk about the Mississippi Valley type deposit that was formed with barite in the matrix of this particular breccia. He didn't point out that the entrance area is actually a fault, but it does correlate there. And like I said, that's the fault that makes that little anecline looking feature right at the entrance. There's also a really nicely displayed and obvious fault up in Quasimodo's lair that I was able to get an orientation on, and that's what's shown in kind of the red dashed, because we only get a brief glimpse of it there. And those probably aren't the only faults in the cave. Now these the blue features are actually surface features that were mapped by a group of researchers from the UT Austin area. And this is without them knowing anything about the location of the cave. I worked with them later and pointed out how much influence it had. But these are faults and features that they actually mapped based on the syndepositional mapping of these faults on the surface. These weren't things where they saw anything going on underground. And then the kind of blue clouds that you see here is basically some work that I did just looking at passage density in the cave to kind of identify maze areas in kind of a digital way, as opposed to just sort of having gone through the cave and saying, hey, yeah, this is really mazy. One of the, obviously some of the biggest maze areas are like the Chandelier Maze and Chandelier Graveyard. Both of those are major breccia zones, and the Chandelier Maze one is particularly striking, as anyone who's gone through that knows, because you're walking down this giant borehole, the Labarge borehole, and then all of a sudden the cave breaks into this immense three-dimensional maze. And then once you get past the ballroom right at the edge of Prickly Ice Cube Room, it goes back up into a big borehole again. All throughout the Chandelier Maze, if you get up where it's not covered with secondary formations, you can see that is one big breccia zone and likely a syndepositional fault. I also would not be surprised if that's the same feature that you see over in the Chandelier Graveyard, because that's also characterized by a lot of this big breccia. So these are zones that can actually let you know that there are, there's a lot going on here. And because these areas were kind of focus areas for dissolution, those are good ways of finding passage, to get into upper and lower levels. This is just sort of a close-up looking at the fault that goes from the entrance. This is looking downhill from in Glacier Bay. And what I've got mapped out, shown there is kind of the breccia zone that marks that particular fault. The white line down on the bottom is actually the height of a caver. There is actually a person in that photo, but you can't really see it. But it's showing the displacement of those beds right there in the entrance zone. And then this is the poor picture that I took of the chaotic breccia zone and boundary of the fault up at the top of Quasimodo's lair. So some of these features are very, very recognizable in the cave. This is a silt matrix breccia where you've got the class of limestone surrounded by a finer matrix. And then quickly jumping to a couple of other places, looking at the influences of these features on Ogle Cave. There's a cluster of features that were marked by Hunt and Kosa that they just called the Ogle Cave Fault Zone because they were able to measure displacement. And again, that correlates strongly with the entrance of Ogle and is probably the reason that entrance is there. The inclined breccia feature is one that I mapped in the cave with the dip. And then Dave Yagnow had actually mapped another one a little bit further back. And those features are probably also strongly control why you suddenly have that connection between the main Ogle Cave level and the upper level off to the east side there. And this is just a plan map of the cave showing the work that Hunt and Kosa did. Again, the red lines are their mapped faults. The yellow ones are the features that they had acted, or they basically guessed that there were faults there, but they couldn't measure a lot of the displacement. You can see that the yellow line there does jive with the breccia feature that I mapped in the cave. And then the lower, the one on the south there is an extension of the silt Neptunian dike feature that Yagnow had mapped. And when you look closely at these, you can see that there's actually pretty good surface expression of these sort of once you know they're already there. Another cave that I've done a lot of work in that has this reflects the same pattern is Virgin Cave. And this is obviously a much more simplified version of the cave. But as many people who've been to the cave had noticed, that there's basically that whole entrance area sort of looks like it's a bunch of cemented breakdown But what it really is a big zone of redissolved breccia. Anywhere you go in there, you're seeing, big calcite spar in between the class as you move a little bit higher in the passage in this big inclined feature. You see a lot more of the silt matrix breccia. And then when you get out of this particular zone, you get into what we think of as more of like real cave, this joint controlled passage that's really obviously different than the maze area that makes up the rest of the cave. So I said that I was going to talk a little bit about definition issues with these breccias. There's a bunch of different types of breccias that you can have in carbonates. I talked a little bit about the four-reef breccia, and that's basically where rubble fell off the front of the reef into deeper water and then got cemented together. You've got fault breccias, which can also be confused with some of the paleokarst breccias, particularly when there's been dissolution around those faults. And then there are paleo channels in the reef, some of which have been identified inside places like Carlsbad, where there was actually like a flow channel in the reef and rubble fell into it that was sort of perpendicular to the reef. So these are all features that can be confused with each other when we don't have a lot of three-dimensional mapping ability. The nice thing is caves do give us a lot more of a three-dimensional view of these features than on the surface. Another problem is these syndepositional faults can change character both laterally and vertically. Like I said, there's a lot of places where as you move up in these features, it goes from a calcite matrix breccia to a silt matrix breccia to where you just have this kind of folded sediment draped over the top of these features where they're almost not recognizable. To really tease out any of these features, you really need to do detailed mapping of their geometry inside the cave. And that's one of the projects that I've got going in particularly in Lechuguilla and in Virgin Cave. So overall, the cave location and shape has been controlled by the regional structure and the paleohydrology, something that Harvey referred to in that diagram of getting that deep-seated circulating water to mix with the hydrogen sulfide and dissolve out the caves. But the individual passage character and some of the cave development has been controlled by these medium scale facies and structural changes, especially some of these syndepositional faults. And those faults can be identified as these associated breccia zones and these Neptunian dikes. So as you guys are going through the cave and putting some of these features on the inventory, it's always real nice if you can actually get them sketched onto the maps, both in plan and profile, because that'll help us really narrow down some of these features and might help us identify other places to look for more breakthroughs. And with that, I can answer any questions.
Thanks, Paul.
Great.
I'll hand it over to Andrea.
Great, thanks. Well, Paul, you totally delivered on some, as you said yourself, some geeky stuff. That was really detailed and really fantastic. I know myself have misidentified some of these small aneclines or monoclines, and so have definitely learned something from this presentation. We are getting some questions in the chat box, and people are asking about, I want to start here with, there was a question, wouldn't the rift qualify as a mapped fissure?
Yeah, it is definitely a mapped fissure, but because I've not been able to measure the displacement of the beds across that feature, mostly because of secondary deposits, I can't unequivocally say that that's a fault. I strongly suspect that the rift actually is a fault or an expression of one of these syndepositional features. But because I can't prove it, I did not want to put it on the map as such. And there are a number of other deep fissures in the cave that I don't have enough kind of data on and mapping on to be able to unequivocally say that that's what it is.
Yeah, the evidence, is in the geology, and it's shrouded by other deposits. So a veil of mystery remains over it, I guess you could say. There's also some talk about, once again, trying to define, using the word Neptunian dike versus fissure. Would you want to kind of reiterate that? I know you had a slide in the beginning about it, but maybe you could go into another explanation of it.
Yeah, basically because what we're looking at is a feature that was open on the surface and allowed sediment to basically pour down into it, and fill it up from above, or the sidewalls would collapse. I prefer thinking of it as a Neptunian fissure. Neptunian really just means it formed underwater or fairly near the water's edge, whereas a dike in the strict geologic terminology is an intrusive body, usually of molten rock, being intruded into another rock. So you'll see Neptunian dike in all of the older literature, but particularly when I'm talking with igneous and metamorphic people, they absolutely hate me using that term. So I've tried to train myself to use Neptunian fissure instead, though you will hear me slip fairly frequently and still using the term Neptunian dike. It's also fewer syllables.
Yeah, we appreciate things that are easier to say, especially in the geology jargon, right?
Right.
Ron Miller here is saying that he saw that fault in the higher education dome photo in the talk yesterday, and that he thought it was spectacular. I don't know if you caught that as well.
Yeah, I did.
Great. And I have, let's see, we have 3 minutes left. So here's another question that I had, that, you use the term dolomatization, speaking of words with lots of syllables, during your presentation. Could you explain why it makes limestone more resistant to dissolution and erosion?
Yeah, basically it just, because of the added, magnesium to it, it makes it less soluble. So when you replace some of that calcium with magnesium, it makes it less soluble, and that's why it's more resistant, both to dissolution from speleogenetic processes as well as surface erosion.
Thanks, Paul. I'm going to ask a rather snarky question from Hazel here. She wants to know, wait, are we supposed to do inventory?
Yes, and in theory, we should also be entering it into the database, but I know there's a huge backlog.
Yeah, but I think your presentation really shows the value of it. I know sometimes, especially if you have exciting exploration to do, people sometimes maybe put the inventory task to the side, but I think this really shows how that information can be used.
Yeah, and on that note, I just want to kind of throw a shout out to all of the people out there who've collected the inventory data and have taken the time to really learn the catalog, and be able to get down to the nitty gritty. Because obviously, as researchers, we can't get everywhere in the cave. So having that inventory database and have it be something that we can search to kind of target areas to go into, we can definitely make our trips into the cave much more efficient. So we can, plan our trips and get to that super detailed information much more quickly than just sort of randomly wandering all over the cave. So I know many people think of it as kind of an onerous task and aren't really sure that it's being used for anything. But let me assure you guys that it is definitely appreciated and it is being used for these, because it definitely helps narrow down our research.
Indeed. I'm going to ask one more question here, but I want to give Harvey a heads up that we'll be entering our 15-minute question time period, and there are definitely some follow-ups that we'd like to ask. So if Harvey is still around and wants to turn his microphone or camera on to join the conversation, that would be great. This question's for Paul from Michael Doe. Are there any plans to push the detail of the limit mapping to consider the more detailed spacing of features indicated on the Lechuguilla Cave map relative to the trends noted at the larger scale?
The hard part on the lineament mapping is that's pretty much all done with various types of remote sensing. So it's really hard to get down to that fine resolution that we can get inside the caves. I have done exercises where I've just kind of drawn lines through the major features of the cave to kind of make an in-cave lineament map and matching that up with the surface. Most of it's stuff that most people can just see by eyeball, but you can do that exercise to get to the fine features, but you're not likely able to see that fine level of detail on the surface because of pesky greenery.
Yeah, it's too bad when that vegetation gets in the way.
Vegetation's in formation, I tell you.
It's like, get him out of the way. Harvey, do you want to unmute yourself there? I had to snort a little bit here. You had the comment that Paul's officially in trouble because he needs to enter that inventory data.
That is correct.
Harvey, I was wondering, Pat Sizer mentioned your great sense of humor, and I was wondering if I could put you on the spot here and ask if you had any humorous recollections from looking at geology in the cave or discussing the cave's geology at a conference.
Well, I need to think about that for just a second. Actually, there are those who don't particularly appreciate my humor because it's the lowest form. I'm a punster. And my daughter-in-law, for example, won't even let me make jokes in her house because she can't stand it. It just makes her cringe. But I'm trying to think of something funny that happened on one of the trips. I'm sure there were lots of them.
Yeah, if you want to take a second to think on that, I can ask Paul another question.
Sure, ask Paul another question.
Paul, this kind of overlaps with some questions that we were having yesterday about the hydrology and the water table. And so Larry Sprengler asks, is the Lake of the White Roses the only place in the cave that actually intersects the water table?
Yes. How's that for a nice short answer?
I like it. So concise, so concise. Let's see here, what else we got? Harvey, I don't know if you had a chance to read many of the comments in the chat, but people really enjoyed your conversation and the history that you presented. Including some of the folks that were in your presentation, including, Ed LaRock said that it was a really nice talk and he enjoyed watching it. And Art Palmer was saying that they've been lurking in the background throughout this entire program and are extremely busy on another project, so not contributing, but they wanted to say what a great show it has been and thanks for everybody, both Art and Peggy saying that, so.
Well, I read a lot of the comments and I'm humbled. I appreciate everybody that helped me out over all of the times that I was working on the inventory project and on anything else in Lech or anywhere else in caving. It's been great. And all I can say is that I don't know how I did it, but I seem to have fooled them all.
That's the greatest trick, isn't it?
There is a bit of a story that I can tell. I don't know how funny it is, but yesterday we heard about food on the caving trips in Lechuguilla. Now, I'm not going to sit here and claim that doing inventory was as rigorous as doing climbs into the higher education room, but we were in there for several days at a time. And it became a bit of a competition on the first night that we were in there as to who could bring the most outrageous item to eat on the first night in the cave. We had ice cream. We had baked Alaska. We had apple pie.
Nice.
Now, I do have to tell you that the meals the second night didn't quite measure up to the meals on the first night, but we had really outstanding things to eat on that first night after traveling into the cave and getting to camp. And so that's not too funny, but I didn't hear anybody mentioning that in the items of food that were talked about for packing up and bringing into the cave.
No, I have to say, I think those are all first that I've ever heard of people bringing. But with that being said, I think we're gonna take a little bit of a break here since we haven't had a bio break yet. Thanks again to Harvey and Paul for putting those presentations together. I really appreciate it. And I'll just say that we'll take a little bio break here and we will all return at, sorry, I want to make sure I say it in Mountain Time, at 4 p.m. Mountain Time. So see you all soon in 8 minutes.